Advances in Data Mining Knowledge Discovery and Applications. This course is brought to you by Gilad James Mystery School. Learn more at giladjames.com. Introduction. Hyperspectral remote sensing is one of the most significant recent breakthroughs in remote sensing. It obtains image in a large number, usually more than 40, narrow, typically 10 to 20 nanometer spectral resolution, and contiguous spectral bands to enable the extraction of spectral information at a pixel scale, so it can produce data with sufficient spectral resolution for the direct recognition of those materials with diagnostic spectral features. Usually classification method of hyperspectral remote sensing data are divided into two categories, using subpixel classification techniques and spectral matching techniques. In the former, the images should not need to atmospheric correction, however, due to higher dimension of hyperspectral image, it will lead to dimensionality disaster and Hughes phenomenon, which refer to the fact that with the number of spectral bands increase, the sample size required for training set grows exponentially. The solution methods usually are increasing sample size, thus this will cost a lot of human and material resources. Another simple but sometimes effective way to solve this problem is dimension reduction of hyperspectral data, but some useful information will be lost. Furthermore, it is hard to solve mixed pixels. In the latter, matched filtering method is successfully used in information extraction from hyperspectral remote sensing image. It classifies by computing the similarity of the pixel spectrum and the reference spectrum, and it needs no sample data, but the image data should be atmospheric corrected beforehand. These methods based on the hypothesis that dark currents of the sensor and path radiation are removed and all spectra data have been calibrated to apparent reflectance. However, it is only the ideal condition, for these effects are hard to be removed completely, so some mistakes will be caused due to atmospheric influence, especially for low reflectivity ground objects. This lecture proposed an unsupervised classification for hyperspectral remote sensing image. It can effectively extract low reflectivity ground objects such as water or vegetation in shadowed area from hyperspectral remote sensing data using spectral data mining. Firstly, extracting more than 40 endmembers from the hyperspectral image using Pixel Purity Index, PPI, and calculating the spectral angle between the pixel spectra and each endmember spectra, the pixel was assigned to the endmember class with the smallest spectral angle. Then, endmember spectra were clustered based on k-mean algorithm. Finally, pixels in the same k-mean result class were combined to one class and the final classification outcome was projected and outputted. Comparing the classification result and field data, they are in accord with each other. This method can produce the objective result with no artificial interference. It can be an efficient information extraction method for hyperspectral remote sensing data.